right? Yeah. I'll refresh this. Okay, okay, I think so. Yeah. I'll refresh this. Okay, let's begin in 1 minute on some music. Okay, uh, let's start. Okay, minimum recolors to get k consecutive blocks. Okay, minimum recolors to get k consecutive blocks. Minimum recolors to get k consecutive back blocks. Recolors. Okay, I have to color a minimum number of times to get k consecutive, so 3 consecutive black blocks. Okay. We're given a zero indexed string blocks of length n, where blocks of I is either W or B. We're given a zero indexed string blocks of length n, where blocks of I is either W or B. Representing the color of the I block, the characters W and B denotes white and black, right? Yeah. We're also given an integer k, which is desired number of the consecutive black blocks. In one operation, you can recolor a white block such that it becomes a black block. Rather, the minimum number of operations needed such that there is at least one occurrence of k consecutive black blocks. So in this case, it's probably WBB, WWBB, WBW. K is 7, so I'll see 1, 2, 3, 4, 5, 6, 7. In this case, I see 3 is the answer. 3 is the minimum answer. Okay, in this case, K is 2, so I can probably go for this, but in this case, I need at least one recolor. In this case, also, I need at least one recolor. In this case, I need one recolor. Um, in this case I need one recolor. In this case I need zero recolor. In this case also I need zero recolors, and I think so in this case I need one recolor. Answer is 0. Okay, and n is also 100, so I can go n square now. I can go n square definitely, or can I not? Okay, I can do this. Yes, I can do this. Instead of going n square, I can create a prefix array of w and b. Yeah, so I can say prefix white, or simply I can say white prefix is initially 0 for I in range length of whatever the heck blocks is, and then I can simply say that my black prefix is going to be almost the same stuff. Okay, I can't copy that thing, so I'll write the entire thing. So length of blocks follows. Done. How do I populate this? It's very straightforward, I guess. Yes. I can initially say that if huh, um, for I in range length of blocks, if I is equivalent to 0, in this case also if blocks of I is equivalent to W, which means 1 second. If it's W, which means that okay, so it's white. I can probably say that white prefix of I plus equivalent to 1. Else I'll say black prefix of I plus equivalent to 1. Else I can probably say that if blocks of um, I is equivalent to W, in that case white prefix of I is going to be white prefix of I minus 1 plus 1, right? Else I can say that my black prefix of I is equivalent to black prefix of I minus 1 plus 1. And in either of these cases I have to by default add the previous one, right? Yeah, so if that's the case, then this is something which is happening. Then I'll say black prefix of I plus equivalent to the previous one itself. In this case that would be I minus 1, and in this case I think so this should be white prefix of I is equivalent to oh, there should be plus equivalent to white prefix of I minus 1. I think so that should be it. So my black prefix and white prefix has been created. I can simply say that for end in range length of blocks, I just need to uh, check if the current window size is k, right? In that case, let's see what we can do. Also, this can be done in a big O of n square time complexity. The reason being it's n is 100 only, but I'm going for a big O of n approach. N square is completely fine. It will pass all the test cases, no worries. So k is capital or small. Let's see. K is small, we can have it as capital or small as well. So here itself, I'll say that my current window length is probably, let's say, end minus let's say my start is at, once again, let's say my start is at 0, so I can simply say my current window length is end minus start plus 1. Yeah, end minus start plus 1. In this case I'll say key, let's say end is here. So in this case I'll say key, let's check how many white marbles I need, right? How many white I need. So I think so we don't even need black prefix. Yeah, we don't even need black prefix. That's it. Yeah, we don't even need black prefix. If this is the case, then this is something which will happen. Black prefix is not at all required, so we can remove this. We are interested in the white prefix now. So window length is this, and I'll check in this window length how many white colors are there. So that will be very simple. Count of whites is, let's say, 0. So I'll say key if start is equivalent to 0. In that case, my count of whites, in that I'll add whatever the heck my white prefix is at the end location. Else I can say my count whites plus equivalent to white prefix of end minus white prefix of I guess start minus 1 if I'm not wrong. And in the at the end of the day I have to keep track of like I have to increase start as well. So all of this by the way, all of this will come into play if window length is equivalent to I guess k. My bad. So yeah, done. And then in this case also I'll increase start, and I also have to maintain the minimum answer. Let's say my minimum answer is the entire length of the array itself, length of blocks. So in this case I'll simply update minimum answer as follows. So minimum answer is going to be the minimum of whatever my previous minimum answer is, and then count bytes should do. End of the day I have to return minimum answer, right? Minimum answer. Let's see if there's any problems with this. I think so there should be. Finished. Okay, your answer is 0, expected was 3. Where did I go wrong? Your answer is 0, expected was 3. So let's say window length is currently something, yeah, and if window length is equal to k, then count points is this. If start is equivalent to 0, then I do this. Y prefix of end, then y prefix start name. I'll subtract that, right? Okay, let me go ahead with this key. Let's say, what will this look like, by the way, white prefix? Let's see. By default, have to add this now, and then here itself I'll say white prefix of I plus equivalent to white prefix of I minus 1. I forgot about that, so run code. This should run fine. 3, 3, and let's say I'll use example test cases. I'll run this. Fail. Okay, wait. Okay, why is it saying fail? Finished. 3, 0, 3, 0. Let's submit this. Accepted. Done, done, done. Let's look at the next question. Time needed to rearrange a binary string. Okay. Okay, time needed to rearrange a binary string. Okay, you are given a binary string as. In 1 second, all occurrences of 0, 1 are simultaneously replaced with 1, 0 or swapped with 1, 0. Okay. This process repeats until no occurrences of 0, 1 exist. Okay, so 0, 1, all occurrences will be swapped with 1, 0 until like no occurrences of 0, 1 will exist. Return the number of seconds needed to complete this process. It's not saying return the minimum number of seconds, but it's saying return the number of seconds. So let's say 0, 1, 1, kind of go ahead with the whiteboard thing. This one. Okay, it's taking a bunch of time. Let's go with a new one. Yeah, it's fine, right? Yeah. Yeah, my net connectivity sounds good. Looks good. Format background, black. Then let's say the input was 0, 1, 1, 0, 1, 0, 1. Yeah. So answer is 4, but let's assume we don't know the answer yet. So how will we compute this? So let's say 0, 1 will be converted to 1, 0. So it will be 1, 0, 1, 0, 1. Again, this 0, 1 can be 1, 0, 0, 1, 0, 1. This 0 will be followed. This will be 1, 0, 0, 1. Will be 1, 0, 0, 0, 0, 1, 1, 1, 0, 0, 1, 0, and then so on. This will continue, but I see this is taking a lot of time because it's just saying that okay 4. So I think so I have to return the minimum number of seconds, right? So 0, 1, 1, 0, 1, 0. How can it be done in 1 second? I mean 4 seconds. Let's see. So for this, if I want to do it optimally, I have to, let's say, shift from the back side, right? So this can be 1, 0, and then 1, 0, 1, 1, 0 follows. This 0, 1 could be 1, 0, so 1, 0, 1, 0, 1, 1, 0 follows. This 0, 1 could be 1, 0, so 0, 1, 1, 1, 1, 0, 0. But this 0, 1 can be, okay, so that's the problem, right? So how are they doing? After 1 second, S becomes this thing, right? So S is it's saying that okay, it becomes 1, 0. This will also, okay, so so at every second, not only one operation, but all of these things are getting converted. So let's say in 1 second, I can say this can be simply 1, 0. This one will follow. 0, 1 can be 1 0 0 1 can be 1 0, that's 1 second. So in 2 seconds this 1 will follow, 0 1 can be 1 0, 1 will follow, 0 1 can be 1 0, 0 will follow. Again in the third second 1 will follow, 1 will follow, 0 1 will be 1 0, 1 will be as it is, 0 will be as it is. So I think so 0 1 is still there, so I'll say again in the fourth second I'll say that okay, 1 will follow, 1 will follow, 1 will follow, all of these three ones. This 0 1 will be converted to 1 0, and again these two zeros will follow. So I think so we only require 4 seconds. So every point it's iterating once and checking for all the occurrences of 0 1. Okay, so it's not like if it's 0 1 1 and I convert this to 1 0 1, so it's not like simultaneously I have to convert this, but it's like block may conversion. Makes sense. So what will be the answer for 1 1 1 triple 1 0 0? It's 0 here, right? Okay, think about this, what could be the answer for this one? In 1 second what can I do? I can write this 0 as 0 itself. This 0 1 can be 1 0, this can be 1 itself. In the second, I mean 2 seconds, this can be 1 0, this can be 1 0, and I think so in the third 3 seconds 1 will follow, 0 1 can be 1 0 0. So this will take 3 seconds, right? 3 seconds to do this. 0 0 1 1. I'll try to write this, return 3, and then just doing a little cheat code here, custom test case. Let's say the test case is 0 0 1 1. Run code. This should return me 3. Your answer is 3, expected answer is also 3. Okay, so this is fine, the understanding is fine, and s's length is 1000, right? So what can happen here? S's length is 1000. Even if I go for a brute force approach, n square time, I think so that will be fine, right? That will be fine. Even if it's 1000, then how many times I'll replace 0 1 with 1 0? It could be not more than 500 times, right? If I take the largest one, yes. 500 times 0 1 0 0 1 0 1 is present, so 1000 length. Yes. So the time complexity would be 500 into 1000, which is how much? 500 into 1000 is 5 into 10 to the power 5, or we can say 10 to the power 6 itself. Yeah. So we can kind of go ahead with this. Let's say in this case, I'll say the seconds needed is initially 0. I can run a while loop with the condition 1, or I can simply say while true or while 1. Any one of these will do completely fine. So I have to create something like a temp string, which is initially empty. Yeah, string initially empty. There will be an index which is at 0. I have to deal with s, which is nothing but my input string. Yeah. To deal with s, which is my input string. So every time I encounter 0 1, that will be 1 0. While idx is less than the length of s, I can say that if I encounter 0 1, right? If I encounter 0 1, what will happen? Or I can just change s in place now. Why do I need to go with temporary string again and again? So since strings cannot be modified in Python, I'll convert it into a list. Yeah, so converted string s to a list. Done. So I don't need to go over s again and again and then convert, put it into a temporary string. That will be quite bad, right? While idx is less than length of s, I can say that if idx plus 1 is less than the length of s, and s of idx plus s of idx plus 1 is equivalent to the representation 0 and 1. I know this is that point itself wherein I have to update this, so I can simply say s of idx, here I'll change that to 1, s of idx plus 1 will become 0. After I'm done with this, I'll increase idx by 2. Why? Because let's say idx is at 0th location. Yeah, idx is here. So I check idx plus 1 as well. This is 0, 1. In that case, I change this to 1, 0. But I also move idx by 2 places. So idx plus 1 plus 2. Done. And once this is done, I can say that, okay, if this is not the case, right? Let's say this is not the case. This is not the case. Else. So let's say if I'm at last. In that case, I know idx plus 1 is not less than s, length of s. In that case, I can say that s of idx will be as it is. Yeah, as it is. I don't even need to change it. Yeah, I don't even need to change it. Else I can simply say idx plus equivalent to 1. It will just simply move. So s may, whatever that value is, it is going to be as it is. Let's say idx was here. Idx plus 1 is less than s. Yes. Less than length of the s. Yes. Then I'll say s of idx plus s of idx plus 1, which is 0, 1. होना चाहिए. No, but let's say it's 1, 0. In that case, again, it will never satisfy. Hence, I can probably say, कि, I can simply move one step forward. Yes. Then I'll check with 0, 1. Yes. And then if this condition is never encountered, so I can probably have something like a flag is 0. And let's say this condition is ever encountered. This is the special condition. In that case, I can say my flag is going to be 1. Makes sense? And end of the day, I can probably say if flag is equivalent to 1, I know there was at least one occurrence of the representation 0, 1. Hence, I can probably say the number of seconds I've taken gets increased by 1. Else, I can probably say that, okay, I need to break. And at the end of the day, I can return seconds. So let's try to use the example test cases and run this. Finished, 4 and 0. Let's submit this. Should probably run if I'm not wrong, because TLE dega, then I have to think about it. Okay, it's accepted. But I think so again, this has taken a lot of time to run. Yeah, 8827 milliseconds is a lot. It's literally a lot. Yeah. But again, I'll not take this because this is a lot. Memory usage is kind of a lot again. This is also a lot. So maybe can think about optimization here. How can we optimize this? Think about this optimization. What could be an optimized way here now? Hmm. Optimization for this would be key. If it's a 0, 1, yeah. But again, in one move, how many times can I do it? Can there be an optimization? Okay, we'll leave this. This is fine. Both of them got accepted. Shifting letters to. Let's see this. Shifting letters to. Okay. Some music. Okay. Shipment address 2. You're given a string s of lowercase English letters. Okay. And a 2D integer array shifts. Where shift of is start I end I direction. अच्छा. Start end और direction होगा. Let's say diagonally. For every I. So for every index, shift the characters in S. So start से लेके end तक मेरे को shift करना है. Forward if direction is अच्छा इतना और shift the character backward is this. So it's cyclic, right? So after Z, Z becomes A. Yeah. Similarly, shifting a character backward means replacing it with the previous letter in the alphabet. Makes sense. So Z becomes A, B becomes A, A becomes Z. Backwards. So let's say if I had F, then F become E. Return the final string after all such shifts to S are applied. Makes sense. Okay. Let's say I'll take the very first one, ABC. ABC shifts are these things. Okay, let's take this one. ABC and the shifts are given. So I'll clear the canvas, confirm, ये record हो रहा है, right? Anyways, so I'm given ABC. My bad. Is it showing this star? Should be good. I don't know. I'm taking job here. Yeah, now it's kind of okay. Don't know. ABC 0 1 0. So there's 0 1 0. Then we have 1 to 1. Then we have 0 to 1. So this is the start, end, and direction for all of these things. Makes sense. Now what I can do is I can think of 0 and 1, this thing, and 0 means shift them backwards. So this becomes what after the first step or the first operation. This is the first operation, second operation, third operation. So after the first operation, this becomes Z, and I'll use the same color code. So this becomes Z, B becomes A, this becomes this is still C itself. What happens? This is done. Second operation, kya 1 to 2. This one shifted forward. So this becomes what after second operation. This becomes what? I'll stick to the same color code. Z will be as it is. A moves forward. That's B. C moves forward. That's D. Makes sense. What will happen after the third operation? Second step is done. First is done. Third operation is saying that okay 0 to 2. So probably I'll pick all of these things, and then I'll say okay shift them forward, right? So Z becomes A, B becomes C, and D becomes E. So I think so A should be the answer. Yes, sir, the answer makes sense. What about this one? DZ, TZ, DZ, TZ. Okay, let's see. So DZ, TZ. What are the inputs? 000. Then we have 1111, and then I can probably say this is nothing but start, end, and then direction. I see. यहाँ पे क्या लगेगा? I kind of learned this quite far, like quite a while ago, but let's see. So it's saying कि 00 में ना क्या करना है? Backwards जाना है. तो backwards क्या हो गया? C हो गया, right? तो CZ, TZ हो जाएगा after first operation. Then after second operation, this will become what? 1 1, right? So this will become move forward ना. So Z अगर move forward करता है तो Z C A हो जाएगा T and Z because it's cyclic. A B C D Z cyclic में आगे बढ़े. So CADS C A T Z should be the answer. Let's see. So C A T Z. Okay. And also this is 5 dot 10 to the power 4. It's completely fine. It's like 50,000. Yeah, 50,000. This is 10,000 into 5 is 50,000. And 50,000 square I cannot do because that will be 10 to the power 8, which is quite far away from my reach. Shifts of I length is definitely 3 because again this will be always 3. Start and direction, start and direction. start I and end I is given as dot length, direction of I is this as consists of lowercase English letters. Okay, what can we do? Think about this. 0 1 1 to 1. Let's look at the very first one itself. ABC है, right? तो ABC को भूल जाओ, अभी एक array बना दो. 0 1 2. What are the inputs? 0 1 0. These are the inputs. I'll highlight them. 0 1 0. So 0 1 0 start and direction. Then we have 1 to 1. Then we have 0 to 1. End of the day, whatever the character is here, right? I have to move it to the left or to the right. Let's say I get the value something like this. Let's say I get to know that the current character is, let's say, B. Now end of the operation, it's saying that B has to be moved twice to the left and once to the right. So what's the absolute value? Okay, B से अगर दो पीछे गए, so that's A, then Z, but again I have to move once to the forward, so I'll end up at A. So why don't I keep the absolute value? The absolute value here will be going back by one step only. So instead of performing three operations, okay, from B, one step I'll go to A to Z, and then Z to A. I'll say, let's keep the absolute value. So from B, absolute is going 2 towards left, 1 towards right, absolute is going 1 towards left, that will be A itself. Yeah. And how do I maintain this absolute value? Let's see. So in this case, I can say कि क्या हो सकता है? Let's change the colors a little bit. This is good. 0 to 1. 0 to 1. क्या करेंगे यहाँ पे? 0 to 1. I'll say at 0, let's have a value 1. At this value 1, ना, I'll say उसके आगे वाले value में let's have it as 1. So okay, the idea is this thing. Currently I'll have 1 and here I'll have minus 1. Done. So whenever we get a positive value, I know key that is moving forward or moving backwards, right? Okay. So whenever I get a positive value for a particular index, I know I'm moving backwards. And whenever I get a negative value, I know I'm moving forwards. This is something I learned way back when I was doing code forces, right? I still do, but it's quite rare right now. So now 1 2, right? But it's 1. So whenever it's 0, I'm adding 1. Whenever it's 1 here, I'm adding negative 1. So 1 में I'll add negative 1. 2 के आगे कुछ नहीं है, else I would have added positive 1. Okay, again it's 1, so 0 में I'll add negative 1. 2 के आगे I would have added positive 1, but that's it. End of the day, what's the entire thing? 1 minus 1 is 0. Negative 1 is negative 1 itself. Negative 1 is negative 1 itself. Again, I know if it's negative, I'll move forward. So it was ABC at the beginning. 0 means I don't need to do anything. A is the very first letter. B में negative 1 है, which means I need to move forward. That will be C. 2 में क्या था? C. Right? Again, which means I need to move forward. Achha, I have to create this thing. My bad. I have to create the prefix of this. It's really my bad. So this turns out to be 0. So this is 0, negative 1, negative 1. If I create a prefix of this, this will be 0, negative 1, negative 2. So in this case, ABC में if I apply this ना, ABC में if I apply A ही रहेगा, B को क्या करेंगे? Negative है, so I'll move it forward. So B becomes C, and the C I'll move it twice. So C, D, E. So A's answer was A's. Done. This is easy, right? Easy. So let's create this prefix, which is going to be 0 for I in range length of chips. Yeah, I think so. That should be it, right? Not length of chips, but should be length of S. Makes sense. What can we do? Length of S. Think about this prefix. Yeah. I'll go over the shifts. Yeah. So for what are the values? Start, end, and then direction. And I can simply say shifts. Yeah, I can say shifts. I can simply say that okay. If start is equivalent to 0, start is equivalent to 0. I don't even need to do that, so I can simply say that if direction is equivalent to 1, then what I'm doing, the direction 1, and then I'm simply subtracting at that location, right? So direction is 1. I'm saying that okay, subtract at the prefix location. So prefix of start say I'll subtract the value, makes sense. And then I'll say if n plus 1 is less than the length of s, in that case I can simply say prefix of n plus 1, may I'll add 1, makes sense, done. Um, um, this is, by the way, the case in this case, right? So I'll do this. Else, the direction is 0 right now, so I can say prefix of start plus equivalent to 1, and then here itself again I'll say if n plus 1 is less than the length of s, I probably say that okay, prefix of n plus 1, may I'll subtract 1, done. Now I'll create the running sum for this prefix array, so that will be for I in range 1 till length of s or length of prefix. I can simply say prefix of I plus equivalent to prefix of I minus 1, and now I know that how will I populate the string. It's very easy. So I can say that let's say my s is, I'll create this as follows. So s को मैंने split कर दिया, so s is list of s. Have some chocolates. For I can have for I in range length of s. So what's the current value? It's nothing but prefix of I. Yeah, the current value is prefix of I. So if this value is negative, right? If this is negative, I need to move forward. So if value is less than 0, in that case I need to move forward. If value is equal to 0, I can say continue. I'll even remove this continue option. We don't even need this. So if value is, let's say, less than 0, because if value is 0, which means I don't even need to move forward or backward. If value is less than 0, negative, I'm saying that move forward. Now, I think so. Let's say this was my alphabets, right? In my alphabets, I mean, let's say my alphabets were A, B, C, Z. Not 25 letters, but this thing. Let's say I'm at A, and the value is -5. Then I need to move 5 times forward. If it was 2 times, 3 times, or 4 times forward, 2 times I will reach B, 3 times I will reach C, 4 times I will reach L. What if it's 5, which is cyclic, kitna bar karna padega? That will be determined by 5 modulo the length of this, which is going to be 1. So I need to move only 1 step forward. Answer is B. So how? 5 times, right? So 1, 2, 3. Wait a second. 1, 2, 3, 4, 5. What if this is, I don't know, 17? Then 17 modulo 4 is 4, 4, 16, 1 again. What if this is, I don't know, 8? Then in that case, I have to move 0 times forward. Why? Because 8 is 1, 2, 3, 4. 1, 2, 3, 4. So I can say in this case, my value is absolute of value. So I know I need to move how many times forward? So that would be value is equivalent to value modulo कितने letters होते हैं? A B C, मेरे को ये भी देखना पड़ेगा. A B C D E F G H I J K L M N O P Q R S T U V W X Y Z. 26? I don't know. पता नहीं. Let's say 26. We will see this, and I just need to move at that location, right? So to move that many times forward, yeah. So if it's A, B, C, Z, if I'm at this location, what will be the ORD value, which is, I mean, the ASCII value? Yeah. That's a little trickier here. So ASCII value would be ORD of S of I, if I'm not wrong, plus value, and then and that should be it, right? Okay, what if I'm at Z and I need to move 3 steps forward? So that will be 1, 2, 3. I will be at C. How do I determine this? Again, this is 3 modulo 4 is 3 itself, right? 4 zeros is 0 and then 3 is the remainder I get. In that case, how do I move this forward? So let's say Z ka this thing was ASCII value was, let's say this is ASCII value 1, 2, 3. Let's say ASCII value 60, 61, 62, 63. Assume. So इसमें क्या हो जाएगा? 63 plus 3 will be 66. And again, I think so I need to do 66 modulo 26. No, that is not the way. What could be the way here? 66 modulo 63. Can I not do that? Yeah. Excuse me. Or better, instead of doing that, from this location, how do I get to know I need to go to B? That should determine that. So I can say, let's say my alphabets are basically this thing: A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, S, T, U, V, W, X, Y, Z. In this case, I don't even need the ASCII value. I can simply say key my S of I. Let's replace that with alphabets of value. That's nothing but my index. Or I can say value -1. That will make sense. Else I know that value will be as it is. So again, I need to do the same thing, but I need to move backwards. So how do we say key? How do I compute the backward thing? So let's say I'm A, B, C, Z, and let's say I'm at C, and I need to move 5 places backward. How do I do that? So 1, 2, 3, 4, 5. What can we do here? So it's more like कि अगर मैं इसको reverse कर दूँ right alphabets को, so it's more like कि okay, opposite way में लेना है, right? So let's say value is value mod 26 itself, and S of I can say alphabets of the reverse one, and then value -1. Kind of might work. End of the day, I have to return my bad. So I have to return S, but I'll join it. And if this is not working, I'll try to run the test cases. Run code. Finished. I'm getting AAB. The answer is ace. Yeah, this is definitely wrong. So let's see what we can do here. If value is 0, then continue. Okay, let's get rid of this. Done. Since there's a problem with this thing itself, let's say this was 25, this was 25. Let's run the code again. Again, it's double AB. So what if I go back to 26, and this is 26 as well, but instead of value -1, I'll say, hey, this is going to be value, right, which is my index. So let's run the code again. It's ZBC. Okay. It's easy now. Why am I making this complicated? I have to take this and go the hard way. Just take a little bit of time. Let's paste this here. Let's get rid of all of this. Done. And then this and then this. Okay. All of these things are good. I can probably say here print whatever my solution is. My bad. Solution dot. What's my function name? My function name is, I guess. Okay. What happened? No, I did not. Okay. I think so. I messed up there. So to do that again. So let's get rid of this and this and this. It's shifting letters, so let's simply have it as S. So solution is right. So here I can say that print solution s, and the function call would be simply to, I don't know, like abc, and then this is required abc. I can simply type in, so this is going to be abc followed by this input right here, and then let's try to see what's happening. Okay, last my answer is ZBC, which is absolutely wrong. So let's see. Prefix is something I know it will be created as I have thought. So prefix, end of the day, what it looks like. Prefix looks like this. Yes, 0, -1, -2. Yes, 0, -1, -2. Done. For I in range length of S, values prefix of I, else this is this. So A should remain as it is. Okay, it's getting changed to something like Z, right? So end of the day, what's my value? Value is 0 itself. Oh, I see the problem here. Ha, ha, ha. Okay. So this was kind of fine. What if I say if value is equivalent to 0, in that case I continue and then I try to run this thing again. What do we get? We get ABC this time, which is the same thing. So I can happily say, what if I do value -1? Okay, I'm getting A, B. Something to do here. Let's see. So if value is equivalent to 0, I'll just type in here. If value is equivalent to 0, I don't need to do anything. So that's continue. Let's visualize this. So my prefix will be 0, -1, -2. Yeah. My prefix is 0, -1, -2, A, B, C. A should be as it is. I think so. Yeah. B, right? So B should move forward and it should give me C, right? So value becomes what? Let's see. Value is absolute of value, which is 1. Value is value modulo 26, which is 1 again. Okay. S of I is equivalent to alphabets of value. Okay. So I need to move one step forward. Hmm. Hmm. That's why it's saying now this thing. This is the problem. So in terms of ASCII, what will that look like? Let's say I am at A का ASCII value होता है 97. If I need to I need to move one step forward. B का ASCII value will be what? 97 plus whatever the move forward value is. In this case, its value. So this will become 98. But what if I'm at Z and move forward value is let's say 3, right? 3. So Z है यहाँ पे A, B, C, and then so on. So 1, 2, 3. C should be the answer, right? How will I find it? Forward is 3. Z का कुछ होता है, let's say 122. If I'm not wrong. What is the ASCII value of Z? Let's see. 122? Yeah, 122. Makes sense. So 122 plus 3 will be 125. And here itself I'll say ki do a 125 modulo 122 again. So that becomes 3. Okay. Okay. So in this case, I can probably say ki what will this be? What's my ASCII value? That's ORD of S of I. So needed is I'll just add a value here. It's kind of making sense. And all of this can be boiled down to modulo 122. Yeah, 122. And then this should be ASCII itself. So A, B, C, 3, right? So we ASCII -1. Yeah. And the same thing will be applied here. So I'll take this thing and then paste this here. Same thing, but here itself again it will be ASCII -1. And let's try to run this again. Rerun this. Last, what did we get? Okay, string index out of range. Okay, we'll see this. Next. Done. Okay. ASCII is 99, right? Which is not something. Okay, so whenever it's 99, I know I'm at the right path because this can be simply said as CHR of ASCII. Done. chr of ASCII, chr of ASCII. So done. So visualize execution. This should probably give me ace right now. Ace. Okay, correct. So the only thing I changed here was this thing, right? So let's copy this and paste it back here. Boom. And I think so we don't even need these alphabets here. So I'll quickly get rid of that. S is list of S, and I'm doing that. So use example test cases. The answer should be what? Ace and cats. Answer is ace, and okay, we got a very randomized value here. Let's see, let's see. Instead of this thing, I got this, right? TZ is fine. I know why that is there. So let's try to run this for something like, okay, which is 0, and this is going to be 1 itself. Let's get rid of this. I hope my recording is still in progress. And then this is going to be, what do we say? CADs, right? Or what's the input here? DZ, TZ, right? So that's going to be TZ, TZ. Okay, let's see what's happening here. 0, 0, 0 and bunch of ones. Let's see. Invalid syntax where line 36. That bracket closes. This closes here. This is for that. So where's the problem here then? There will be one more bracket. I don't know. Okay, there's again a problem here. I see, I see. So this should be there. Sorry, this should be there, and this is the bracket which comes here right now. So this is giving me some big random value, which is completely wrong. So let's try to analyze this. Close. Then click on next, 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 next. What does my prefix look like? It looks like this. So I need to move one step backwards. That's going to be C. One step forward. That's going to be A. 0 means as it is. 0 means as it is. Makes sense. So in this case, value is not 0. So I need to move one step backward. Yes. So value becomes value modulo 26. So again, this now right now this will be 1 modulo 26 is 1 itself. So ASCII becomes ORD of S of I, which is Z plus 1. So this is 122 plus 1 is 123. Yes, 123 if I'm not wrong. And ASCII will be 1 at the end of the day. ASCII will be 1. Let's see. ASCII is 101. Why is it so? ORD of S of I is what? It's DA, right? So D में क्या हो जाएगा? 101. 101 है. Okay. Okay, this should be like, what am I doing, man? This should be like a negative because I'm going backwards. Last. Again, this is problematic. Let's see why. So C is kind of fine here. I think so. C came right? Okay, now C is coming right. So C comes as it is. Yeah, 99. So that will be 97, 99. C comes up. Yeah. What about Z though? Values as in 0. Yeah, it is. Value is this thing 1, and then ASCII value becomes 1. So S of I is CHR of ASCII, which should be okay. So I can introduce something like ASCII value is less than 97. I add there, so that's it. At least I can do this, right? Least I can do this, so I can probably add something in 96. Visualize, and this should give me cats. So one small improvement I need to do here is says a negative value, and right now I need to do something like this key if ASCII is less than 97. In that case, ASCII plus equivalent to 96, and I think so the example test cases would be good to go. A's and cats, I'll submit this, try to see if it's fine. Okay, we got a wrong answer here just because X was getting violated, right? YWXC, CQI is fine. X के लिए it's a problem, right? Let's see. What's the problem with this X thing? So it's very fine. It's not a problem. I think so. I can replace it here itself. Let's quickly get rid of that. Paste this, and what can we do next? This is the thing. Let's do this and visualize execution. End of the day, we are getting this thing which is wrong, right? So this is at 0, 1, 2, 3, fourth location, right? Fourth location. So what's my prefix, by the way? Prefix is still getting updated. Once my prefix is done, I'll check what my prefix looks like. Yeah, so my prefix is this one, right? Yeah, this is my prefix. -1, -2, so 0, 1, 2, 3, 0, 1, 2, 3, fourth. At the fourth location, I was getting the wrong answer, right? At the fourth location, I was getting wrong 0, 1, 2, 3, 4, the fourth index. So it's saying that at the fourth index, 0, 1, 2, 3, 4, move 4 steps backward. So D say if I move 4 steps backward, right? Or 0, 1, 2, 3, 4. So if I move B say 4 steps backward, so B say A to Z, Z to Y, then to X. So X should be it, right? X should be it, but I'm getting this thing. So let's see what's happening here. I should be at the fourth index, so let's skip most of the things. For when I becomes fourth, I'll be interested. Yeah, I is fourth. Value is this thing. Value model 26 is what? 4 itself. Yeah, 4 itself. So currently value is 4. ASCII is going to be quality of S of I minus value. Oh, okay. So when I do that, ASCII value becomes 94, right? Ah, hmm. How can I improve this? Think about it. So minus that thing plus 122. How do you do this? I can do that, but not really sure if it's going to work or not. 96. Last IDIQI. It's a really bad answer. Let's have it as 97. Let's go to the last. Again, it's a very bad answer. What about 122? Might make sense. Last YFC. Okay, to think about this. Think about this. How can we readjust this value? Hmm. What is 122 minus this thing? Hmm. Okay, so 122 plus 94 modulo 122. There's no modulo operation here. Hmm. Yeah. Hmm. X is where? Z, X, Y, Z. Teen, right? So if that's less, then I do 94, 97 say teen. Okay. So Makes sense. So what if my ASCII value, if my ASCII value is less than 97, right? In that case, I can say um, ASCII will be nothing but 97 plus 97 minus whatever my previous value was. So that should be what? Should be 122 minus this. So अभी 119 हो जाएगा, which is 19, 20, 21 plus 1, I guess, if I'm not wrong. Visualize. This should be kind of fine. Yeah, it's fine. QII. Yeah. So I just need to add this line. If my ASCII value is less than 97, then it becomes that okay, ASCII is equivalent to 97 plus, in fact, 122 minus 97 minus whatever my ASCII value is plus 1, and I think so we are good to go for this test case. Run code, and I think so. Yeah, I'll submit this. Oh man, it's still wrong answer. Okay, so X AX LUG SSS. Okay, I got this right. Z के लिए I got this. What can we think of? And this is very big one, right? Okay, let's copy this thing, and there's only way to let's paste this here itself. Boom, and this is giving me a problem where at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18th index, right? So 18वें index पे I just need to go when I is 18. Prefix is still being computed, blah blah blah. Then when I is at 18, right? It gave me the answer, but when I is at 18, where is I? 18 पे क्या है कि turns out my value is what? Turns out my value is -3. So I need to move this thing, which in this case is 0, 1, 2, 3, 4, 5, 6, 7, 8, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, 18. It's at the 18th index. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 15, 16, 17, 18. So W ko I need to move 3 steps forward. So W, X, Y, Z. So it should be Z, right? Yeah, it should be simply Z. So I'm getting this thing. Why is it so? Let's see. So value is 3, makes sense. Value is equivalent to value modulo 26, which is kind of fine. So this becomes a 3 itself. ASCII is simply ORD of S of I plus value, which in this case would be it will be some value modulo 122. Turns out that ASCII value is 0. And then I'm doing this thing, right? So when it's 96, I know ki cyclically it's that thing. This needs to be improved here, that if it's if it's less than equivalent to 97 or less than hmm. Should be It's a problem. Okay, what's the very simplest way I can think of right now? Let's think. Forget about this. This is making it more complicated than ever. So let's get rid of this. Think about the simplest way. A, B, C, D, E, so on till Z. Let's say B ka ASCII value I get it as 98 and the value I'll move forward is 5 times. How will I get 1, 2, 3, 4, 5? How will I get G? That's going to be 98 plus 5. My new ASCII value is this thing. That's it. Which is 103. So that's 98, 99, 100, 101, 102, 103. What if I'm at WXYZ? So W is 102, 121, 120, 119. W is 119. What if I say कि 119 पे I need to move 5 steps forward? That will be 124, which is out of this thing. So how do I get कि यहाँ से 1, 2, 3, 4, 5? How do I get this B, which is at 98? How do I get this 98 का value? It's again very simple. You do 124 modulo 122, which will be I guess 2. Then simply I'll add this to 96, which gives me 98. This thing is done. This thing is absolutely done. So if value is less than 0, I know कि value को मैं कर दूंगा absolute of value, and then I'll say कि okay, value mod 26, value mod value is equal to value mod 26. Yeah, that should be it. And then I can probably say कि if my value is well within 122, it's completely fine. So s of I becomes what's my ASCII, by the way? ASCII, I can simply say SC is going to be ORD of s of I plus value. So I'll simply say if my ASCII value, if my ASCII value is less than 122, then I'll say it's going to be ORD of CHR of ASC. Else, if it's out of that, then I'll say s of I is CHR of 96 plus ASC modulo 122. Done. Okay. Else में क्या आएगा देख लेते हैं. Let's say A, B, C, D, E, F, so on till W, X, Y, Z. Now I am at, let's say, this value, which is 121, and I need to go 3 steps backward, which is going to be 121 minus 3, which is 119, right? Oh, no, 118. So 118 will be V, right? So, okay. So right now I can say that my new ASCII value will be ORD of S of I. Again, value I can simply say it's going to be value modulo 26. This will be this minus value. So if it turns out that my ASC is greater than equivalent to 97, in that case I can happily say that S of I is going to be CHR of whatever the heck my ASCII value is. Else I can say my S of I is going to be the CHR of, let's see, let's say I'm at B, and B's ASCII value is what? 97, 98, right? 98 if I say that okay, I need to go 5 steps backward, that's 1, 2, 3, 4, 5. I need to get W. How will I get W? How will I get W? That will be 98 minus 5, which is 93. How will I turn 93 into something like 190? That will be what? 97 minus 93 is what? 4. And then from 122, I'll subtract 4 and then 1 more. Okay, I'll subtract this thing now. So I can get 119 plus. So I think this is 96. So 96 minus 93 is going to be 3. So from 122, I'll subtract this. So that's 1, 2, 3, 4, 5. W I get 119. So this should be 96 minus the current ASCII value. And out of all of this, I'll subtract 122. I'm 100% sure this will work right now. Like literally 100% sure. Submit. Yeah, accepted. So making things complex there by doing some random calculations here and there. Okay. Maximum segment sum after removals. Okay. Maximum segment sum after removals. What could this possibly mean? Fruit and nut chocolate. Okay. Maximum segment sum after removals, right? So maximum segment sum after removals. So in this case, I can say that okay, you're given a zero, you're given two zero indexed integer arrays. Sorry, given two zero indexed integer arrays, nums and remove queries, right? Okay, nums the and remove queries the okay. Both of length n. Okay, n. For the ith query, the element in nums at the index remove queries I is removed. For the ith query, let's say for the first query, the element in nums at the index remove queries of I is removed. Okay. Splitting nums into different segments makes sense. A segment is a continuous sequence of positive segment sum is the sum of every element in the segment. Yeah. Return an integer array answer of length n where answer of I is the maximum segment sum after applying the ith removal. Note the same index will not be removed more than once. Constant is also very good. 10 to the power 5. Okay. So in this case, it's saying that nums is 1, 2, 5, 6, 1, remove queries is 0, 3. So I need to remove 0th index, then 3, then 2, 4, and 1. So what can we do in this case? So using 0 to indicate a removed element, the answer is as follows. Query 1, right? So query 1 is saying that remove the 0th element, nums becomes probably like nums will become what? 2, 5, 6, 1, and the maximum segment sum is 14 for segment 2, 5, 6, 1. Makes sense. Removing the third element, so in this case I think so this and this is separated, so 2 and 5, answer is 7, right? Yeah. Remove the second element, in this case that should be nums, so becomes 0, 2, 0, 0, 1, and then 1, right? So answer is 2. Answer is 2. Fourth one, then I know answer is 2 itself. Remove the first element, then answer is 0, right? So yeah, we return this. It makes sense. Okay, did I just turn on the radio? I think so. Can we apply segment tree here? Can we apply? Answer is 13, 16. 2. Answer is 11. 5 by 2 remove किया ना. अच्छा 5. 3 remove किया तो 1 remove किया तो answer is 3. And then of all are removed, then answer is 0 itself. Okay. It's more like this key. I need to compute the sum for that given segment, right? Segment tree I can go for, right? 3 to 11 1. 3 to 11 1, right? So let's say it's 3 to 11 1. 3 to 11 and 1. So in this case, if it's saying that, okay, I need to split at third index, let's say I need to split at this index. So what I'm saying, I'm essentially setting this value to 0. So what will my segment tree look like? My segment tree will look something like this. That initially at the tree beginning, I have 0, 1, 2, 3. So 0 to 3 sum is there. It will be something, I don't know what this will be. When I split this into equal halves. So this will be 0 to 1 and this will be from 2 to 3. When I split this will be from 0 to 0. This will be from, I guess, 1 to 1. When I split this will be from 2 to 2. This will be from 3 to 3. Segment tree concept. It's very basic and nothing much going on here. So uh, let's assume that this is the base case. So at 0 I return 3, at 1 comma 1 1 1 I return 2. So 3 and 2 gets added as 5, and I'll add 5 with something here, which is something I'll get from here. So let's just be patient here. 2 2 will be 11, 3 3 will be, I guess, what's the value? It's indeed 1. So I'll say, okay, this is 1. 11 and 1 gets returned, so this is 12. 12 and 5 both add up to 17. Okay, done. Now whenever they give me a query, okay, third index pe we have to remove it, right? So we just need to remove the value at this whatever the heck the third index is. So in this case, let's kind of change the colors to green. This looks good. So I'm saying key okay, I'm saying key go down and change the value at this index, which will be 0. So if this becomes 0 now, then I need to check for all these subsegments, right? That is the problem here. If this becomes 0, I can say key this one will be what? Again, recomputed as 11 0 is 11 and 11 5 is 16. So end of the day, I think so this will give me the answer, right? Give me the answer if I'm not wrong. No, this would not really give me the answer. Let's see why. Segment, it is saying segment. So currently it's 16. Let's say 16. Then I'm saying okay, remove at the second index. So this becomes 0, 0 and 0 becomes 0, and 5 and 0 becomes 5 itself. Again, my answer is 5. First be 16, 5, and then saying that okay, remove 1, this becomes 0, this becomes 3, this becomes 3, answer is 3, and then 0. But again, this was very lucky that 3 to 1 0 was given. What about this one? 1 2 5 6 1 1 2 5 6 1. Let's see this. It's 1 2 5 6 1. So from this will contain the answer from 0 to 4. This will contain the answer from 0 to 2. This will contain the answer from 3 to 4. This will contain the answer from 0 to 1. This will contain the answer from 2 to 2. This will contain the answer from 3 to 3. This will contain the answer from 4 to 4. Again, this can contain the answer from 0 to 0. This can contain the answer from 1 to 1. So in this case, I can probably say that this is the base case, base case, base case, base case, base case. Simply fill up the values 1, 2, 5, 6, and 1. Then populate them up. So 1 and 2 gives me 3. 3 and 5 gives me, I guess, 8. 6 and 1 gives me 7. 7 and 8 gives me, my bad. So 7 and 8 gives me 15. Now the queries are as follows: 0 3 2 4 1. So my queries are as follows: 0 3 2 4 1. So 0 3 2 4 1. I'm accessing the very first query. It's saying that okay, change this to 0, so this becomes what, 2. This becomes what, 2, right? So I think so this would be 7, followed by 7. 7 is 14. This is how it changes. So it's log n time. Just to change it, it's log n time, not n time. This is log n time. Now, in this case, how do I determine what's the maximum value? I think so it's 14 itself, which is the very topmost value. What about if I remove this guy, which is third one, right? Okay, third one I'm removing, which is in this case this one. So this becomes 0, 0, 1 populates down to 1, 7 and 1 populates down to 8. So in this case, I think so the answer is 7. The reason being, okay, this is getting invalidated. Third one mein kya ho gaya? This is getting invalidated. So Answer is 7 just because 2 and 5 gives me 7. 1 gives me 1. Maximum of 7, 1 is 7, and 8 should not be it. 7 is something I'll get from this end. How many times remove queries is there? N times, right? So if I go for it, then n square is the time complexity. I think so. I need to go for a better one. In this case, it would be n log n. This looks like n log n solution only, not more than that as well. Or n could be n. I don't know. Could be n as well. But it's an order, right? I cannot change the order as well. It's a good problem. It's a good problem. Interesting. I'll try to solve this and then go to sleep. Else it's not worth it. Hmm. Okay, why do I not have the segments? I can have it. Yeah, so let's say I have the segments here separately. Initially, the segments were 0, 1, 2, 3, 4, right? I said that, okay, remove 0. So the segments I do have left with me is 1 to 4. So that's my answer only, right? Then this is the first step. Now, second step, it's saying that, okay, remove the third index. So the segments I have is 1 to 2 and then 4 to 4. Make sense? Okay. But again, to get the answer for 1 to 2 and 4 to 4, that will be log n, right? Okay, what if this was something like this 0, 1, 2, 3, 4, 5, 6, 7. I removed, let's say, 2 and then I removed, let's say, 5, or let's say I removed 6. In this case, I'm looking at the segment 0 to 1, 3 to 5, and then I guess 7. So this, just to compute all of these things, that's going to be how much? Log n each, that's 3 into log n, which is again log n itself. In the worst case, what it could be, this I can compute for like 100% sure I can compute this. Let's say I store this as follows. Let's say I store the segments as 0, 1, 2, 3, 4, 5, 6 in a segments list. And here I say, okay, 3 is removed. So I say, key, go from the starting. Let's say my start is this thing and my end is this thing. So I say, key, 3 is been removed. So my new ending will be what? 3 minus 1, which is 2. So in this case, this will be 0, 1, 2. That's my first segment. And I don't think so. I need to store all the numbers. I can store the segment as follows, right? It's going to be a little complicated. So my segment will look something like this. Segment will be simply two numbers, 0 till 6. That's it. 0 till 6, or I can simply represent this as follows, 0, comma 6. Someone comes and tells me that, okay, 3 is being removed right now. So what I'll do, I'll split this as 0 to 2 and what do we say? 0 to 2 and 4 to 6. Someone comes and tells me ki, acha, remove 5, right? Remove 5. So how will I find 5 kahan pe hoga? I can do binary search for that. Yeah. So binary search करने से I can find 5 की यहाँ पे हो सकता है, right? So if I see that 5 can be in this segment, I can say okay 0 to write it as it is. Hmm. Uh, 4 6 this can be simply 4 comma 4 and then this can be simply 6 comma 6. 5 split it up, right? Whenever it's 6, I know this has to be entirely removed, and then so on. I have to compute the values for the rest of them. What could be the thing here? I think so. That can be applied, but the problem is that I have to split this again, na? So if I need to split this again, then problem to hoga. I have to again compute this and then remove this and then split it. Okay, what can be done then? Think about it. What if I maintain a maximum heap? Maximum heap if I maintain. So 0 to 6, the sum is x, right? And then let's say I get an index 2, then in that case I split this, and while splitting I get a 0 to 1, whatever the sum will be. In this case, sum can be computed as, let's say, x1, and then I'll have something from 3 to 6, which will be x2, and again this will be popped off from the maximum heap. Right now a max heap will be organized properly. Now, in this case, what I can say is key I get a second index, let's say 4. How do I split this, right? This could be at the first. So in that case, I can say key 4. I can say key, okay, let's store this in a temporary thing. And then whenever I encounter something which is in between the range of 4, I can probably say key, okay, let's kind of split this to 3 comma 3 and whatever the sum is, let's say x3, and then this could be simply 5 to 6, which could be of some x4. Yeah, can do this. Again, time complexity is very much, right? N square log in हो जाएगा. एक तरफ I'm removing all of those things and then that's the problem now. How do I optimize this? Segment tree was kind of close because where is the segment tree? Yeah, segment tree approach is very close to this. So for example, I get rid of this. So I'm saying that, okay, this value becomes 0, right? So if this is 0, then from this step onwards, I need to split it, right? So if this is 0, then I know कि 0 से 1 तक कितना हो सकता है. कितना हो सकता है, कितना हो सकता है. How much is the time though? It's 2:08. Okay, let's say I am at this कि बोला कि इसको 0 कर दो, right? So when this gets down to 0, I'll say what's the value from the left hand side, and that will not do favor for me, no? What if earlier this was 0? That's the problem. Let's freshly compute this thing. Let's say for 1 2 5 6 1. Okay, say 1 2 5 6 1. So this is 0 1 2 3 4th index. So this value is going to contain 0 to 4. Then if I split this, this is going to look something like this. This is going to contain from 0 to 2, this is going to contain from 3 to 4, and again if I split this will contain from 3 to 3. Let's have the orientation properly. 3 to 3, this is going to be from 4 to 4. Again if I split this, this is going to be from 0 to 1, then 2 to 2, and this can be again from 0 to 0, and then 1 to 1. So in this case, 1 2 5 6 1 is there, right? So 1 2 5 6 1 comes up. I add them, so that's 3. I add them, that's 8. I add them, that's 7. 8 7 is 15. Now what are the queries here given to us? Queries is as follows. It's a 0 3 2 4 1 0 3 2 4, and I guess 1. So I can write it as follows: 0 3 0 3 2 4, and then 1. Okay, done. Now what can we do here? This is nothing but my segment tree. Segment tree, जिसमें major factor है, it's log n. Yeah, the major factor is log n itself. What can we do? Zero. Okay, 0 comes in. So I say ki currently my answer is what? Unknown. Yeah, my answer is literally unknown. Infinity. Unknown. I guess my answer is uh, none. Initially. When I say कि 0 में split कर रहे हैं, so I say कि let's turn this down value to 0. Let's turn this value to 0. So let's update this to 0, right? So this gets down to 0. When this is 0, I update back the segment tree. So this becomes what? This becomes nothing but 2. 2 and 5 becomes 7. 7 and 7 becomes 14. Done. This is what the updated segment tree will look like if I set that to 0. Done. How will I compute the maximum segment sum? Currently, I say कि अच्छा 0 was removed, so my segment will be from 1 till 4. So I can compute from 1 till 4 what is the sum. In this case, that will be uh, that will be 14 itself. Hmm. 0 has been done. What about 3? If in 3 now, if I just change this to 0 and I again readjust this, this will be looking like this will become 1 and then 7 and 1 becomes 8. Yep, 8. सेगमेंट ट्री में है अभी ये 8 बन गया राइट. So this 1 4 can be split into 1 2 2 and 4 2 4 because uh, so 1 to 2 I compute the sum and 1 to 4 4 to 4 I compute the sum. I take the maximum out of this, max out of this, and for this one this was the sole maximum. Now when I process 2 I'll say okay, let's quickly just turn this down to 0. So 2 and 0 turns out to be 2 itself, and 2 and 1 turns out to be 3. Again, when this was encountered, I'll say okay, current segment is 1 to 1 and then 4 to 4 itself. So I'll compute the maximum of both of these persons. In this case, it's going to be 2 and really 2. Ha, it will be 2 itself. Makes sense. Ha. So like 1 to 2 का कितना था 7, but in this case it's 1 to 1 which is 2 and then 4 to 4 which is 1, so our maximum is 2 itself. Done. So in this case I got the answer as, where is it? In this case I got the answer as 14, in this case I got the answer as 7, in this case I got the answer as 2. The very last one is I think is if we access 4. So if we access 4 this becomes 0, this also turns out to be 0, 2 and 0 becomes 2, updated to 2. Again, since it's probably 4, I can say that okay, let's remove this, and the only segment I'm dealing with is 1 and 1. So in this case, I can probably say key, let's remove this answer variable, 1 and 1 I'm dealing with. So 1 and 1 may, I think so the answer would be 2 itself. So the answer to this is 2. So notice one thing carefully, key, it's not like it's always increasing, but it will decrease at certain point of a time, right? 1 to 2, 4 to 4, and then this thing came and then probably it decreased, right? So it's not like it forever increase. But the problem here is again, how do I split this properly? Okay, I'll take a look at this later on, or should I look at the discuss thing and try to see if I can get some hints. Union, okay. No need of segment tree. Okay, so I was going the wrong way. Sets and prefix some solution, tree map, and log n, yes. Do it backwards, pick off, and priority queue. Okay. Okay, it's saying do it backwards. What could be the hint here? He, I get this all to zeros, then I make the, okay, first को available किया मैंने, so that turns out to be, okay, let's look at Python 3 and then do it backwards. Python 3 priority queue is there. Let's look at this thing. Please pull this grid command here division. Here I use order set to restore the points which now are divided. Hashtag this. See, they're also doing the same thing, right? And they're trying to find that thing, binary search, low, high. But what's their time complexity? What is a sorted list? Sorted list is like, why do people ask this? N log n. Okay, I'm really tired right now. I'll probably close this and try to do this tomorrow. Tomorrow's Sunday, so we can end up do this tomorrow. So I close this session. I did the very first three. I got 7, 5, 12 points nonetheless. So I'll close this.